So we're going to start this section on Java concurrency by defining a few key terms that you need to know as they relate to Java. So I'm going to start off using the term a process, and that's a unit of execution that's got its own memory space. Now each instance of a Java virtual machine, the JVM, runs as a process. I guess that's not strictly true for all JVM implementations, but really for most of them. And when we run a Java console application, which we've been doing a lot of this course, what we're doing is we're kicking off a process. When we run a JavaFX application, we're kicking also off a process as well. Now, many people will use the terms process and application interchangeably, and we will, in fact, have done that in this course, and we'll do that in this section as well. So if one Java application is running and we run another one, each application's got its own memory space, also known as the heap. So the first Java application can't access the heap that belongs to the second Java application. So in other words, the heap isn't shared between two applications or two processes. They each have their own. Let's talk about a thread. So a thread is a unit of execution within a process. So each process can have multiple threads, and in Java, every process or application has at least one thread, and that's the main thread. For UI applications, this is just called the JavaFX application thread. In fact, just about every Java process also has multiple system threads that handle everyday tasks like memory management and input-output. We as the developers of Java applications don't explicitly create and code those threads. Our code runs on the main thread, which is created automatically by your Java program, or in other threads that we explicitly create. And in this section of the course, you're going to be learning how to create these threads. So creating a thread doesn't require as many resources as creating a process. And the thing to remember is that every thread created by a process shares that process's memory and files. And this can cause big problems with your applications, and you'll find out about that in a later lecture. Now, in addition to the process's memory or heap, each thread's got what's called a thread stack. And the thread stack is memory that only that particular thread can access, and we're going to look at what's stored in the heap versus what's stored in the thread stack in a later lecture in this section as well. So every Java application runs as a single process, and each process can then have multiple threads within it. So every process has a heap, and every thread has a thread stack. So I guess at this point you might be asking, why would we want to use multiple threads in our application? Why not just stick with the main thread as we've been using in the course? What are the advantages? Well, there's two main reasons why you'd want to do this. Firstly, we sometimes need to perform a task that's going to take a long time. Now, for example, we might want to query a database, or we might want to fetch some data from a website on the internet. So we could do this on the main thread, but the code within each thread executes in a linear fashion. So the main thread wouldn't be able to do anything else while it's waiting for that data to come back, or from the database or from the internet. So another way of putting this is that the execution of the main thread will be suspended. So it has to wait for the data to be returned before it can execute the next line of code. And to the user, this could appear as if the application has died or is frozen, especially when we're dealing with a UI application. And if you've already been through the JavaFX section of this course, I did show you a simulation of locking up a UI application where it appeared to be frozen, waiting for a particular thread to finish. So these are big problems that we need to avoid as developers. So instead of tying up the main thread, what we can do is create another thread and execute the long-running task on that thread that we've just created. And what happens there is that frees up the main thread so that it can continue working and executing, and it can report progress or accept user input and perform those other tasks on the screen or in other parts of the program, while that long-running task that we kicked off in another thread continues to execute in the background. So that's the first reason you might want to do it. But the second reason we might want to use threads is because an API requires us to provide one. Now, sometimes we have to provide the code that will run when a method that we've called reaches a certain point in its execution. So in this particular case, we usually don't create the thread, we pass in the code that we want to run on the thread. And we'll see examples of this later in this section as well. So that now brings us to concurrency, which refers to an application doing more than one thing at a time. Now, that doesn't necessarily mean that the application is doing more than one thing at a time or at the same time. What it means is that progress can be made on more than one task. So let's say that an application wants to download data and draw a shape on the screen. So if it's a concurrent application, what it can do is it can download a bit of data, then switch to drawing part of the shape, then switch back to downloading some more data, then switch back to drawing more of the shape, and so on. So what concurrency really means is that one task doesn't have to complete before another one can start. And the good thing here is that Java provides thread-related classes so that we can create Java concurrent applications. So that's a very short explanation of some of the terminology. So don't worry if you're having trouble grasping these concepts. Concurrency is something that's best learnt by example. So we're going to move on in future videos to creating some threads so you can see how these work by analysing the Java code itself. But before we do, we really have to understand that when working with threads, we're at the mercy of the JVM, the Java Virtual Machine, and the operating system when it comes to when the threads are scheduled to run. And as a result, or because of that, output can vary from run to run, and you might not see the exact same output that someone else sees when they run an application on their computer that uses concurrency. As an example, we can't guarantee in which order lines will be printed to a console because of the very nature of threading itself. But that's it in a nutshell. Let's start in the next video going through some practical examples of how threads work. See you in that next video.